You can use dilations to create enlargements and reductions of figures. Transformations change the position or size of figures on the coordinate plane. An image is the result of a transformation. A dilation is a transformation that produces an image similar to the original figure. So we said their angles will be congruent, but the sides will be proportional. The scale factor is the ratio of the original and new dimensions. If a scale factor is greater than 1, the image is an enlargement, which is larger than the original figure. If the scale factor is between 0 and 1, the image is a reduction, which is smaller than the original figure. So the first problem says, create an enlargement of triangle ABC so that the sides of the image are twice the lengths of the sides of triangle ABC. What are the coordinates of the vertices of the image triangle ABC prime? Okay, so I would definitely underline or highlight that we want to make it bigger. It said enlargement. And another keyword was that they said to make it twice the length of the original. So they're telling me that my scale factor is 2. And whenever you have the scale factor, they're telling you what to multiply by. I will multiply by the scale factor. Okay, so it says multiply the coordinates of the vertices of the triangle by the scale factor. Step 1, they want me to write out the originals. So if I'm looking at the original A, remember I always start from the origin. It is right 1 and up 5. I'm going to write it like an ordered pair should look. Okay, forgot to turn on my fancy light. If I'm writing the coordinates of B, it is right 1 and up 2. So that's 1, 2. And C, if I start at the origin, is right 3 up 2. So it's found at 3, 2. Alright, so they're giving me steps. They said multiply the coordinates of the vertices of triangle ABC by 2. So they've listed out, now what I should have got, 1, 5, a 1, 2, 3, 2. And then they show me, take that first coordinate, the 1, they're multiplying it by 2. And then they take that second coordinate, the 5, and they multiply it by 2. And they did the same thing here with the 1 and the 2. They're multiplying them both by the scale factor of 2 on the last one. They're multiplying them both by the scale factor of 2. So since these are notes, we're going to highlight to do a dilation. You are multiplying by the scale factor. So I'm going to have my new points. Let's see, I'm going to have a 2. If I multiply that, I get a 10. A 2 and a 4. 3 times 2 gives me 6. 2 times 2 again gives me 4. It says to plot points A prime, B prime, C prime on the graph and draw triangle ABC prime. Draw a ray from the origin to each vertex of triangle ABC. Notice how the vertices of the image of triangle ABC prime also lie on these rays. Okay, so I need to start plotting my new one. Remember that you really do want to label the points as you go so they don't get mixed up. Okay, first point is at 2, 10. So I'm starting at the origin, right 2, up 10. Label is A prime. Okay, B prime is at 2, 4. C prime is at 6, 4. whenever y'all do problems, make sure you complete it and draw it so it looks done. Okay, so our goal was to make the sides of this triangle twice as long. So if I want to check my work, I can see the original bottom of this triangle was just 2, and now it spans across 4. So it did get twice as big. The height of this triangle was 3, and now it's 6. So it does look like it got twice as big. My angles, if I want to point out, we had a right triangle, and it's still a right triangle. So the angles, even though my triangle got larger, it was an enlargement, my angles stay congruent. That is a property that you need to know. Write it out to the side. Angles are congruent. Congruent? That doesn't look right. Oh. That's a lot better. Alright. For dilations, angles are congruent. Okay, what did they say? They wanted us to draw rays from the origin to each vertex of triangle ABC. Notice how the vertices of the image of the new one also lie on these rays. Okay, so it wanted me to start from the origin. I'm going to go to A. You don't need a ruler, just kind of sketch it out. They wanted to show that if you keep on going straight, you should hit the new one. So let's see. B and B prime, C and C prime. So as long as your origin is the center of dilation, which for all of your problems it should be, this should happen. So if it looks like something doesn't line up with the original, if you're trying to like trace it back to the original and keep on going to the origin, that would be a sign that something wasn't right. Okay, so it wants us to list what are the coordinates of the vertices of the image. Okay, so we've got A prime was at 2, 10. B prime was at 2, 4. And C prime was at 6, 4. Another example. Create a reduction of triangle ABCD. No. Of trapezoid ABCD so that the sides of the image of trapezoid ABCD prime are 1/4 the length of the sides of trapezoid ABCD. Okay, they're giving me the scale factor, and that's always going to be what you multiply by to get your new coordinates. Okay, so there's our trapezoid. They have very politely written out the originals so I didn't have to go and get them. And they set it up just to help guide me to show we're taking the first coordinate and the second coordinate, and they're multiplying both of them by the scale factor in each one of these ordered pairs. So I want you to highlight that part to show we are multiplying by the scale factor. Okay. Whenever you get to this part, if you need to punch it into your calculator to get it done, that's fine. But here we go. -4 times 1/4, so I'm just getting a fourth of it, is going to be -1. 0 times this scale factor is still going to be a 0. This one starts off the same, so I'm still going to have a -1. 4 times 1/4, so I'm going to get a fourth of this number is 1. It happens again and again and again, and then I get a -1. Okay, so I did that without a calculator, but I would rather you can try to do it, but definitely check your brain with the calculator because you can. I don't want you to miss it. Okay. Well, it'll be a clue. If you graph it and it doesn't look like a similar shape, there's a clue. Okay, so here we go. -1 and 0. I'm starting from the origin. And I'm going to go left. And it said 0, so I don't get to go up or down. And I'm going to label that as A prime. -1, 1. So I'm going left and up. And that is B prime. 1, 1. Right up is C prime. It is so little. And 1, -1. 1 and down. Okay. And that would be D prime. Okay. Well, that A is in the way, but okay. I'm going to draw it. So it's looking pretty good. And it looks like if I did start at the origin and go to the original, that new one, since it's a reduction, I would cross it. Like it looks like it all lines up. A is easy to see because it's on the x-axis. And D lines up also. Okay. Easy enough.